Portable electronics have become an essential part of our society. I'd be willing to bet that everyone here owns a laptop, a cell phone, and maybe even a tablet. One key piece of technology in these devices that gives us the freedom to use them almost anywhere is a lithium-ion battery. These batteries have had an enormous impact on our everyday lives and are expected to play a large role in the widespread use of new technologies such as electric vehicles. Because of this, the environmental impact and sustainability of lithium-ion batteries needs to be seriously considered. My research is focused on developing new materials to store the energy in these batteries in order to address these issues. Metals such as nickel and cobalt are major components in today's lithium-ion batteries. From an environmental standpoint, making these materials is a nightmare. Toxic chemicals such as cyanide, arsenic, and sulfur dioxide are generated in the mining and processing steps. Additionally, these materials are very costly. About 5 to 10% of the cost of a brand new electric vehicle comes from these cobalt and nickel materials in the battery. Although recycling programs are in place, they're plagued with inefficiencies, and these materials are unsustainable in the long term. One way to deal with these problems is to replace the nickel and cobalt materials with organic ones. Organic materials are made of highly abundant elements such as carbon, hydrogen, oxygen, and nitrogen. One of the best things about organic materials is that nature makes them all the time. By taking a close look at what nature is making, we can design batteries based on these biologically derived materials. This way, we can let nature do most of the work, and then we can just finish the job with a few quick and easy steps. By taking a look at a number of different biological compounds, I found that molecules that have charge transporting roles in biological systems are the best candidates for batteries. Specifically, I've taken a look at vitamin B2 because it has a high charge storage capacity, allowing it to store more energy if used in a battery. Working with Professor Dwight Seferis, I've developed a lithium-ion battery that uses a plastic made out of vitamin B2 to store the energy. Being a plastic, it can offer several advantages, such as low processing costs, the ability to be molded into different shapes, and it'd be flexible, allowing it to be used in new technologies such as wearable devices. All steps to make the vitamin B2 plastic can be designed in a way to generate only organic waste. This can be naturally recycled within the biosphere, thereby making it a sustainable cycle. Right now, I'm working on developing a new synthetic method in order to further reduce waste and to make a material that is able to be reused thousands of times in order to compete with what is on the market. This strategy of using biologically derived materials for energy-related applications is an effective and sustainable way to both reduce cost and reduce the environmental impact of our increased use of portable technologies.